Welcome to Engineering Scale Models. I'm Jason, your host, and I do models. We are looking at our Make Electronics again. We're going to be doing the next experiment, Experiment 4. This is messing around with the potentiometer. If I can, you think I would have, here we go, right here. We are. Okay, so here we go. We'll get the basics electronics fun off, and we'll look at our book here. Experiment 4, variable resistance. We're going to need a 9-volt battery, a 470 ohm resistor is what I have right there, and a 1K resistor, and 2 LEDs. I have one, and then I have drawers full of LEDs. We got our alligator clips because we're not using a breadboard yet, and I have a 1K potentiometer right there, linear potentiometer. Oh, I need 2 of those apparently, so I have 2 of those. And then I need a multimeter, and I do have 2 multimeters. You only need 1, but I'm going to run 2 because I want to show you how the current works on these. So the first thing I'm going to do is I'm not going to use the meter in the corner of the screen because the singlet SDM3045, even though it is a fantastic piece of equipment, I have got some issues with the way the screen is set up on the computer, and I have to work through that. And I don't like the way that I can't go local and from the unit, so I'm going to work on figuring that out. But right now we're going to look at the resistance. We're going to turn resistance on our meter here, and you can see that. Yeah, you can see that pretty well. Okay, so we have resistance. It's auto ranging. So if I take my potentiometer, and let me see if I can zoom in here and just show what I'm doing in the meter. Does that help the meter? It helps the meter a little bit. So I'm going to clip on the 2 outer leads of this potentiometer, and I get a reading of 900.923 kilo ohms, so about 1K within its range of tolerance. But now what makes this a variable resistor is if I clip on to the middle here, I have about 2 ohms there, and if I go all the way, I start turning it the other way, I'm at a half a kilo, 534 ohms, and as I go, I can crank back up to my full range of about 927, and then I can go back down. So that varies the resistance. And if you remember in our last experiment, lighting the LED with different levels of resistors, it changes the brightness and the amount of current that flows. So the lower the resistance, the more current that flows, and the higher resistance, the lower the current is. So we're going to do something you're not supposed to do. I'll turn the page because destructive experiment of head. It wants us to connect directly from the potentiometer to the LED and turn it all the way down. So if I connect to the middle and I go this way, okay, so I'm going to use the middle and this one, and I am at, this is going to be 1,000 ohms between the resistor and the battery. So what I'm going to do is I'm going to come in here like this, and I am going to set up this meter for current, because we want to measure the current through this. So I'm going to go to 200 milliohms, and we're going to set this up here. We're going to use a battery connector this time to make easier connection to the circuit. So I'm going to connect this on there, and then I'm going to connect the black to the black of the current meter. Okay, that's that right here. This will all be made much easier when we have a when we have a breadboard. So then I'm going to take the black from the current meter and plug it into the middle. So now I have a connection from negative to the middle of the potentiometer. And then I'm going to take, using a red one, well actually I'm going to use a black one because that's the negative side. So we're going to plug that, and we're going to plug it into the short lead of our LED, the cathode. That's the short lead, the cathode. And then we're going to plug the long lead into there and connect it to the battery. So the LED has lit, and it is of a certain brightness. I'm going to set it right there. So now we are drawing 3.4 milliamps. Okay, now yeah, we're not going to use the other meter, so I'll turn that off. Okay, so we have the LED right there. There's really no way to hold this. So now I'm going to slowly turn this and lower the resistance through the potentiometer, and the LED should get brighter. Turn that off. Oh, that my eyes needed to adjust to go on that bright light going off. Okay, so you see the LED and you see the meter current. It's at 3 milliamps. We'll take it to the 20 milliamp range. So it's at 3 milliamps, 3.3 milliamps. Now, if well, no, I don't want to do that because it's going to go pretty high. So I'm going to slowly turn it. Turning it, you see the LED getting brighter, and you see the milliamps rising. So now we're at 3.7 milliamps. And we're going to see if we can catch it, because this is going to make the LED blow when it goes to zero current. When it goes to zero resistance, the current is going to skyrocket and the LED is going to blow. So we're at 5 milliamps. Okay, there's all the way at zero resistance. So it's 7 milliamps. It's still a little bit, it's still lighting. That's because there is resistance in my amp meter. So I'm going to pull the amp meter out of the circuit here. So I'm going to unhook my amp meter. I had a feeling that that was going to happen, but I just wanted to show you what the current was. So I'm going to take this green one, and I'm going to show you guys what happens. I'm going to turn it back to full, and then I am going to reconnect it here. Okay, so the LED is dim, and I'm going to crank it up, and it's getting brighter, and it is still staying lit. Normally that would fry an LED. I wonder if there is some kind of like major resistance and then these cheap components. Well, anyways, adding zero resistance to a LED and putting it across the battery will normally short it out. So I'm going to attempt to replicate that by disconnecting this and putting 9 volts directly across the LED and see what happens. Wow, 9 volts, it's taking 9 volts. And what does 9 volts directly across the LED look like? 6 milliamps. So that is current limiting somehow. Let us see if we can discover why this is being current limited and not shorting out this LED. See, if you look in the book, it says begin, start, turn all the ways counterclockwise, otherwise you'll burn out the entity before you get started. So in theory, this should not be lit. And I am wondering if this battery even can put out enough current, if it has some kind of current limiting in it. It is zinc carbon, which is a very crappy form of battery material. So the LED is still lit directly off 9 volts. You can see there is no resistance in there, and it is drawing milliamps. Let us check the power of the battery and see what kind of voltage the battery has. Battery has 8 volts. And 9 volts dropped across. The LED wasn't even getting hot. Let's check this diode. Let's check this diode here. No, past it. That is the most annoying beep in the world right there. So positive, negative. That's weird. Today nothing is working out. I've made about 3 videos and nothing seems to work out here. I'm not getting a diode reading off of the seat. It's just sometimes these meters, I just can't stand them. Let me check this meter, because this is why I have multiple different meters, because sometimes you get crap. Let's select diode. So this is why I wanted the good desktop bench meter, because I don't get these kind of fluctuations. Okay, so this can tell me it's an LED and it has a forward voltage of 1.8 volts, and I'm dropping 9 volts across it. Should blow it. Let's see if it has a resistance with the Transistor Tester. It's a little component tester that will tell you aspects of it. Let's see what it tells us here. Flashes it once. It should give us the forward voltage. Forward voltage, 0 capacitance. You know, it's just telling me it's a diode. Okay. I'm not understanding why this won't blow this diode. I got all excited thinking I was going to blow a diode for you. And it was like, I made this video yesterday because I didn't want to blow the diode. Then I was like, you know what? I want to blow the diode for these people. It's not even that bright. Okay, well. Well, I'll tell you what I'm going to do. I'm going to do this for you guys. I am going to turn on my... Not that one. I am going to turn on my power supply, my singlet SPD 3303XE, and I am going to set my voltage for 9 volts, and I don't want to do, I'm going to do 50 milliamps. So actually, you know what, I could probably go over one more and do 10 milliamps because that won't blow it. So here's 9 volts across the LED right here. 9 volts across the LED now. So there's 9 volts at 1 milliamp. So let us do 2 milliamps. It gets a little bit brighter, and it's still drawing the 2 milliamps. There's 30 milliamps, I'm sorry, 30 milliamps, not 2. That was 20, 30. So this is the maximum range of an LED, and it wants to draw more. It's in constant current mode. If I go to 40 milliamps, it still wants to draw it, but it is going to, is it going to die at 40? 50? Yep, 50. 60. 70. Oh, there it goes. It dimmed out at 70 milliamps. 80. 90. 100 milliamps. It is just about shot. 110, and it just blew. It just flashed one last time. So let's turn off my power supply. Okay, so we fried this LED, and just to prove that we fried it, we're going to, and that's what happens when you don't have any resistance. The amperage just gets out of control, and I just did that in a controlled manner that allowed us to, you know, safely do that. Should have been able to do it across a 9-volt battery. I don't understand that problem. So if we check the diode, it is an open circuit. No forward voltage either way. Nothing. It's just a blown LED. So that will go in the garbage, and we will get a fresh LED. Fresh LED. Ooh, one with longer leads. That's exciting. So then we will check a new LED here. The kit comes with extra LEDs, and this has got a 1.8 forward voltage. Okay, so let's turn this back on so we can see. So that is that part of the experiment here. So now that we've whipped out 3 different meters, and we've used a power supply to blow the LED, because it is not going to blow with a 9-volt battery for some odd reason, and I can't explain that. Maybe someone in the comments can figure out why that wouldn't do that. Just, I don't understand. It was confusing. So it tells you after you blow the LED to put a resistor in line with the battery to stop it for when it gets to 0 volts, and, you know, to check the forward voltage and see the difference. So you're actually building what's called a voltage divider. You can overload your meter by drawing too many amps. We checked the amperage on it. You know, it says with 1 kilowatt it would draw 9 milliamps, and with 2 kilowatt 4.5. We got a little bit different with ours. So, and then it talks about Ohm's law, how you can figure out the difference for current, amperage, current, volts, and resistance. And then it talks about parallel and series circuits, and then it talks about how big, you know, how much you need to drop across the resistor to, you know, make the LED only have 2 volts, and that's, we just disproved that whole process. And then we're going to talk about power, wattage and power, and then experiment 5 is let's make a battery. We're going to skip that, and we're going to take a look at experiment 6 is using switches. Talks about some tools, the breadboard. We're just going to work on the experiments here. So we got some other different type of potentiometers, trimmer ones. And then we have a very simple switching circuit. So we need a screwdriver, wire cutters, strippers, the hookup wire, 9-volt battery, LED, the 2 toggle switches, 480 ohm resistor, and again we're going to be messing with the alligator clips. So that's going to be the next experiment, guys. Thank you so much for sitting through this, and I don't know, every time I turn the camera on something weird happens. Either my brain malfunctions or the parts malfunction. Thank you so much for watching. Here's the links to social media, and here's the link to my Patreon page. If you can help support the channel, maybe get me an education, that would be useful. Thank you so much for watching, and have a fantastic day.